Hello and welcome to today's lesson where we're going to look at internal energy, which is part of the particle model of matter topic for GCSE physics. So in today's lesson we're going to try to understand what internal energy is. Now if we're successful and we learn in today's lesson, we should be able to define what internal energy is, understand how internal energy is calculated and link the internal energy of a substance to different situations, which forms part of the GCSE physics specification 4.3.2.1 internal energy, which is found in the particle model of matter topic. So in the particle model we should consider all forms of energy stored in the particle structure, and in a particle structure there are two forms of energy store, which is the case if the particles are atoms, molecules or ions. All particles have these two energy stores. Now, the first type of energy store is a potential energy store. This is due to the intermolecular forces of attraction between the particles. The second energy store is the kinetic energy store. This is due to the particles moving around. Now, in the particle structure, these two stores combine to form the total energy of the particles in the actual object, and we call this the internal energy of the substance. So the internal energy is equal to the kinetic energy plus the potential energy, but because we're working the internal energy of the entire object, that means we've got to consider all of the particles in the object. So when we say kinetic energy, we mean the kinetic energy store of all of the particles, and when we say potential energy, we mean the potential energy store of all of the particles. So the particles within a system are a kinetic energy store, which is due to the fact that they are constantly moving or vibrating. The particles are also a potential energy store due to the intermolecular forces of attraction between the particles. The sum of all these particle kinetic energy stores and potential energy stores represent the body's internal energy, which is equal to the total kinetic energy plus the total potential energy. So to summarize these ideas, we can consider the following example: that all objects, substances, are made out of particles. Now, the energy that these particles have in total is called the internal energy of that substance. Now, part of that internal energy is the kinetic energy store of the particles, which is how much the particles vibrate or move. Now, the kinetic energy store can be changed by changing the temperature of the substance. So, increasing the temperature of the substance increases the kinetic energy store of the object. So, therefore, that would increase the internal energy of the object, which is achieved by heating up the substance, by putting work into the system. The other part of the internal energy store is the potential energy store of the particles. This is how much the particles are attracted to each other. So the potential energy can be changed by changing the state of the object. So this can be increased by changing a substance from a solid to a liquid to a gas. So carrying out this change of state will also change the internal energy of the object, which again is achieved by heating a system, by doing work into the system. So the internal energy is equal to the kinetic energy store plus the potential energy store, but it has to be considered for all of the particles in the object. So to clarify, the formal definition for internal energy is it's the total energy of the kinetic and potential energy stores of all of the particles that make up a system. Increasing either the potential energy or the kinetic energy will result in an increase in internal energy, and this takes place solely by heating the object. This means that changing the conditions of the object, the external situation the object is in, will not change the internal energy, because these stores we're looking at in today's lesson are internal to the object. They're not combined with the external stores that are present in the object. So this means if you want to change the internal energy of an object, you must alter the particles of the object. So to change the kinetic energy store, which would change the internal energy store, we must increase the temperature or change the temperature. Now, changing the temperature of the substance changes the kinetic energy store and therefore the internal energy store. Changing the potential energy store will also change the internal energy store, which occurs when the object changes state. So changing the state of matter of the object will change the potential energy and therefore the internal energy of the substance. Now, you may only change one energy store of internal energy at a time. When work is done, only one store can be altered at a time. So when you're changing the kinetic energy store, you can't change the potential energy store. When you change the potential energy store, you can't change the kinetic energy energy store. So this means to a human, when an object changes state, it doesn't change temperature. But when an object changes temperature, it does not change state. This means you can either change the state or the temperature at a particular moment. Now this leads to an important idea and just links into the concept of temperature. So when a substance is heated, the particles will move or vibrate faster as the average kinetic energy in the particles has increased. So temperature is related to the average kinetic energy of the particles in a substance. So for example, a substance at 24 Kelvin would have particles with on average less kinetic energy than a substance at 200 Kelvin. Now we can refer to the kinetic energy store of particles in an object as the thermal energy of the object. So heating changes the energy stored within a system by increasing the energy of the particles that make up a system. So this would change the temperature if the energy put into the system alters the kinetic energy store of the particles. Now this can change the state of matter if the energy alters the potential energy store of the particles. Now when an object has a temperature of absolute zero Kelvin, the particles have no kinetic energy. They no longer move. So this, like we said before, is called absolute zero, which occurs at minus 273 degrees. So a more rigorous definition of absolute zero would be that at absolute zero, the internal energy of an object only consists of potential energy, as the kinetic energy store is zero. So to summarize today's lesson, energy stored inside a system by the particles that make up the system is called the internal energy. Internal energy is the total kinetic energy and potential energy of all of the particles that make up a system. Heating changes the energy stored within the system by increasing the energy of the particles that make up the system. This either raises the temperature of the system or produces a change of state. So if we've been successful and we've learned in today's lesson, we can define what internal energy is. We can understand how internal energy is calculated, and finally we can link the internal energy of a substance to different situations. I hope you've enjoyed today's lesson on internal energy, which links into the particle model of matter topic in GCSE physics, and I hope you have a lovely day.